Yeah, it's just not like when after graduate, when you're looking for a job during the interview, they ask you, have you ever worked with microcontroller? You say yes. What type of microcontrollers? Arduino. It's a little bit embarrassing, right? So you need to know what are these mainstream units being used in the industry. And I think ST is pretty much the best one so far. It has really high quality and a lot of functions, and also it's compatible with the 32 kHz crystal. So 32 kHz means it's way lower frequency, means low power design. So you can design a wearable device using this 32 kHz instead of 16 megahertz, and save a lot of power for the battery. Okay, go to the website. You can see there are 3 tutorials. They're pretty simple. It's just for 2 weeks. We cannot make really long tutorials. And to be honest, I don't have time to develop more tutorials for you guys as well. What about the stress level for now? For group 2, I know you guys, some of you guys are in robotics 2 as well. So what about the stress level this semester? Working with multiple projects. Okay. Did you spend a lot of time in senior SEM? I don't think so. Oh, already a lot? Oh, paperwork and all these, got you. The proposals and these things. Yeah. What about others? And plus research. Yeah, exactly. Okay, hopefully you learned a lot. You learned a few, if not a lot, hopefully. And okay, so for MSP430, so the experiments are simple. So I give you a little tiny Bluetooth module, and you can download the app to your smartphone, and you can use a voice decoder in that app. You just talk to your phone, and the phone can translate it and send a signal through Bluetooth to your MSP430 and turn off the LED or do something else. As long as it is able to receive the signal, it can do a lot of other things. If you are using your microcontroller to control a robot car, then you can use your voice to control the robot car, right? You can tell the smartphone something. So you're not working on the signal processing, the natural language processing, because the smartphone is going to do the job for you. It's actually pretty simple. After you talk to the phone can recognize it and send it to the Bluetooth module and the microcontroller. It doesn't have to be MSP430, it can be Arduino. I just showed you some different projects. I just don't want to keep repeating the same projects as what you have done with Arduino microcontrollers. Let's take a look at that. So we have 3 tutorials, right? 2 for MSP430 and 1 for ST32. Let's take a look at MSP430 first. So this is from Texas Instruments. Used to be super popular, in the past 20 years. Now it's getting less popular because there are so many other options, especially for the ST microcontrollers, Arduino, and the ESP. So MSP430 used to be a big star, but now it's not. But you still can see a lot of tutorials, instructions, and projects are using MSP430 for low power design, and for people who are like normally older than 40 years old. I'm a little bit less than that, so I'm not a big fan of it, but it's okay. Let's take a look at it. It's a 16-bit computer system compared to Arduino. It's a 8-bit, right? So this is a 16-bit. And if we look at the pin out after this, we can tell what are the functions this microcontroller has, right? But now look at other options, in the features. If you open the data sheet here, you can see on the top of the first page are all these features. whenever you are trying to adopt a new microcontroller, you want to look at this first. So you need to know, is this a 16-bit computer system or 8-bit computer system or 32-bit computer system? So apparently this is 16-bit, and the logic is the voltage high is low actually. It's from 1.8 volts to 3.6 volts. It's pretty outstanding, which means you can really design something to operate in low power consumption. It's not even 3.3 volts. Something lower than that can still work. Is for the logic. So what we are using here is going to be 3.3 volts for the power and everything. And it does have an internal frequency up to 16 megahertz. And also, it is compatible with a 32 kHz crystal. You can add a 32 kHz crystal. You can buy it from DigiKey and solder it to the board. It's very interesting. How do we do that? So take a look at the board, the right one. And so for this kind of commercial product, you can definitely find out the schematic and layout online. I already have the link on the website. I'm going to show you. Yeah, I didn't bring the camera over. If you look at the schematic, you can open the link and see the schematic. Let's take a look at it. A couple pages. Which one is the microcontroller? Which one? There are so many IC chips on the board, right? So which one is microcontroller? The biggest one? How many? Huh? It only has 20 pins. If you look at my controller, it's a dip. It's not this guy. So the one on the top is a USB to serial converter. Actually, it's for debugging purpose. That's why it has so many pins. It's surface mount chip, right? But the real microcontroller is actually here at the lower end. Only 20 pins, I guess. Is that 20 pins? Yeah, 20 pins. So this guy. Crystal, where can you connect crystal to the microcontroller? So remember, if we want to drive a barebone microcontroller, we need the power, we need a crystal. That's pretty much everything. Power, ground, crystal. So crystal is here. X in, X out. And then we scroll down to find out X in and X out. So we're here, crystal selection. I'm pretty sure you are pretty familiar with this kind of circuit, right? You have two capacitors and one crystal. And it's 12 picofarad. You can see it's disconnected to the pin. And where is that guy? Where is this? So if you grab the board and you look at the board, on the right-hand side of the microcontroller, there's a little surface mount device, looks like a crystal oscillator, right? It's a little bit different from the one you used, but looks like it's, at least it's not a capacitor or resistor. Did you see that one? And that one, on the left-hand side of that device, has two surface mount pads, but without anything on the top. So that two parts are these two pins, actually. So if you do not solder, short these two pins together, it's saying it's a resistor, but the resistance is 0. You can directly short it. If you do not short or very low resistance, okay, that doesn't matter. If you keep it open, it's not using this 32 kHz crystal frequency. It's not selecting this frequency for the controller. And if you put something here, short it to here, then you can activate this 32 kHz crystal for low power design. I mean, we normally want a pretty fast computer system, but why, or what kind of application can we use 32 kHz instead of 16 megahertz? Can you name some of them? Anything in real life? You don't need that high frequency, but can still be fine. But low power, lower power. Digital watch, yes, exactly. Because the digital watch is, the frequency is 1 hertz. If you use a 60 megahertz, you have to divide. It's oscillating so hard, but you are saying, I don't need it. I'm going to divide you by 60 mega times down to 1 hertz for my little second. Okay, so you can use a 32 kilohertz, which is way lower than that, to create that 1 hertz clock. And what else? So this Casio, this digital watch is like $10, can last for 10 years without swapping the battery. They must have used some of the really low frequency crystal in there. What else? What about temperature meter? Like for the pool sometimes. Okay, because the temperature of the pool is not changing every millisecond, right? It's probably won't change for minutes. So do not need that high resolution. You just detect the temperature and take the time. I mean, 32 kHz is not really slow. I mean, it's oscillating 32,000 times a second. You can still, provide a pretty decent velocity or frequency to drive all this sequential logic in the microcontroller. For I2c protocol even, it's kind of just take the time to do it. Doesn't matter because the temperature of the environment is not changing that quickly. So that's another application. So these are all the parts on the board that you have, the right color PCB board. And now let's go back and take a look at the pinout. So what does this microcontroller have? So before we move into there, what you expect? At least, let me know. Just name it. What you expect for a commercial microcontroller? I2c, SPI, serial, ADC, GPLs, right? Now let's find it. What are they? Where are they? That's power 3.3 volts. It's a timer, clock for the timer, and timer as well. But you can see here, SOMI. Sounds familiar, but not exactly the one we saw in the past, right? The one you saw in Arduino is called IMI-SO, MOSI. So what are they? Remember what are they? Yeah, but what's the protocol? What's the pin? SPI? So that's SPI. So how many pins do you need for the SPI communication? 4. Enable, clock, in, out. Okay? So IMISO, MOSI, SCLK, and enable. So we already have SOMI, SIMO here. What about clock? Where's the clock for SPI? Here, SM clock. It looks different, but it's SPI. There's a clock for SPI. Yeah, where's the enable pin? Yeah, maybe. I don't know. I couldn't tell right now, but there must be one. So if you look at the data sheet, they will tell you what are these pins used for. What are these modules and what are the pins for these modules. So we already found SPI, and also you can see that for the pin 3 and pin 4, they also have RX and TX. So they are the Uart communication is also here, also in the same pin. So Uart and SPI are in the same pins. And ADC clock, that's a clock for the ADC. Probably sometimes they need a different clock, so they allow the user to input a different clock frequency for the ADC for sampling. And next, yeah, it's something else. No. So it can be used as a general GPIO, which is P1.4. That's port 1 dot 4, right? So that's the fourth pin of, actually fifth pin of port 1. All right, these are the GPIO pins, but also the timers as well. And that's a crystal. And this is reset and something else. And this is, what is this? What is this? That seems like another SPI here. And also, what is this? What are these two pins? I2c. You see only two lines, SDA and SCL. And also A6, A7. So they are the ADC inputs, right? So this guy, I don't know how many ADCs it has, but it does definitely are trying to multiplexing these different ADC inputs, right? So you can have 8 ports, 8 ADC inputs, but you can only have one ADC inside. It's trying to multiplexing. It's enable this one, sample it, and enable the next one. Just do it really quickly. You don't need that many ADCs because ADCs have a lot of op-amps inside. It's taking a lot of space inside the chip. So I don't know if they really have 8 ADCs. Normally they only have 1, but different ports. All right. And I2c, and these are general GPLs and timers, and that's it. So you are reading this microcontroller as reading a book. That's what I saw from a comment from a video online a couple of days ago. Like Bernie Sanders predicted every single word. Did you see that video? You didn't. Bernie Sanders was interviewed by Jimmy Fallon, and it's just Google it. It's just like he predicted every single thing was going to happen in the next 2 days, every single one. So here's the IDE, and that's not the IDE actually issued by TI. This is a third-party IDE. It's very simple to use. But we have another one. I think I forgot the name. Composer is something composer. I forgot. But that one is issued by TI. It's more professional later on. But this is good for now, I think. I was trying to get more tutorials by using that IDE, but we'll do it later. So let's focus on this one for now. It's just 2 tutorials. And you can tell what's the difference between these 2 IDEs. And this is you don't have to install it. After you download it, you can directly open from a folder on the hard drive and start running it. So follow the steps here to install that, not install actually, just to download it and put it in the hard drive. Okay, and run a blink first. So here's something you need to know. look at the wire jumpers here. You have to rotate it 90 degrees for just these two wire jumpers to enable the serial communication or debugger in real time from your microcontroller to the IDE. So which means if you want to send something from the microcontroller to the IDE to the serial monitor on the computer, you have to do this. And at the same time, it doesn't matter if you do this or not whenever you are trying to upload the code to the microcontroller. So the easier way to do it, just to keep it like this all the time. So you will be fine. So this is what you can see on the serial monitor. So keep in mind, this is not Arduino, okay? This is Energia, what's the name of that? Energia. Okay. And there's a very simple example. So you're going to use a potential meter to give a different voltage input to this analog pin. And because whenever the voltage changes, it's going to directly give a different brightness for this LED because it's an analog voltage. And this voltage will be received by the pin, by the A0 pin, which is analog input. So the microcontroller can digitize that voltage and directly use that digitized number. So because this is a 10-bit ADC, so it's going to be 0 to 1023, and you can directly use that number as a time delay in terms of milliseconds, right? So it's going to be 0 milliseconds or 1023 milliseconds, which is actually 1 second, right? And you can use that one as a time delay to blink another LED. It's a very simple code, and I already provided here. Here's a hardware connection. And if you are using all these male header pins or wires, you can flip it and insert to the back of the board. You can see the female headers on the back and male headers on the top. Pretty interesting design. All right, so that's tutorial 1, works for 20 points. So keep in mind, this tutorial, this homework 4 is 1 homework assignment. And tutorial 1 was 20 points. And tutorial 2, I think, is 30 points, I guess. Let's take a look at this. You are going to use the Bluetooth module, HC05. I already gave it to you. Make the connections. So the Bluetooth module has a PCB antenna on the top, and that antenna can communicate with the antenna inside your smartphone. All right, and your smartphone has definitely can download that Bluetooth app, right? So download that app, and they can type whatever to the app, and send the data to your microcontroller through the Bluetooth module. So here's a hardware connection between the HC05 and your MSP430. Serial communication. Okay, take a look at the video, see how I did it. And since I don't have an iPhone, so if you are using an iPhone, you probably wanna have to figure this out by yourself. I just don't have it, so I couldn't get a demonstration video for you. But I think it should be pretty simple. If you can find out the same app, it should work. Shouldn't be a problem. So the first one is what I did over here is I just type something and directly send it to the microcontroller and then look at it in the serial monitor, I guess. And the second one is the voice command to control an LED. Okay. So if I say on, right, so it's going to turn on this LED. If I say off, it's going to turn it off. If I say blink, it's going to blink. If I say burn yourself, couldn't understand it. it's not that smart. And OLED display, you have used OLED in another experiment, right, for the temperature monitor, and make the connection. That's I2c. And I don't remember I have any pull-up resistor because I believe the OLED module has pull-up resistors inside, like your MPU accelerometer. So just do the same hardware connection. You should be able to make this work. I couldn't remember since I did it in May or June, I forgot. And I think for the very last one, what I was trying to do is use a Bluetooth module and use my smartphone to text to my MSP430. For example, I text hello world and it should show up on OLED. So I send it from my phone to the HC05 Bluetooth, and the Bluetooth module will send it to the microcontroller use serial, Uart, TXRX. And then the microcontroller will process it and display it on the OLED display. So remember that actually was the door project I was trying to give to the high school kids. It's similar, but it's not completed yet. So I was trying to, for example, if I'm going to leave my office, I want to leave some comments or notes on the door. I'm going to text it, open the app, and text like, Dr. Lee is on the third floor lab. If you have questions, just go there to meet with him or something like that. So this can be the project to serve that purpose. But I forgot if I bought it, so I think Denzo still have it. I haven't. We don't have time to make it work, but that's a good idea actually. I like it. Okay. Mm-hmm. If we go further with this project, you can imagine if I connect something or mount something on the door, I definitely need it to be low power. I don't want to have a wire and plug into anywhere inside the office, right? It needs to be part of a battery, and it needs to be low power. And I think 32 hertz may work, but we are not doing that for this for now, right? You just make it work, and we're done. But I think in the future, this need to be low power, need to be part of a battery, and low power. Whenever nobody tags to it, it should be in idle, right? And turn off the monitor, to save the power. And I think 32K hertz is good enough. There's no why not, right? I mean, should be fine. Yeah. I forgot, if this code fully functioning or not. I think what I had a little problem, I guess, back in June when I was trying to text to the OLED display. I think it's not handling the length of the text really well. So if I text hello, I think it's fine. But if I text really long, like Dr. Lee is on the third floor, it's just not receiving all the text. Try it. I forgot. So try it and see what's the result, and try to modify if you can. If not, which is fine, just repeat whatever I have here, which is acceptable. We only have 2 weeks. I don't expect you can get a product out of it. Yeah. Maybe it's too long, so the Bluetooth is not going to, the app is not going to send it at one time or something. I don't know. Some bottom level communication protocol need to be figured out. So that's the first one, or the second one. That's the second one already. Yeah, that's the second one already. So let's take a look at the ST. So it's going to be a different IDE. You have to use that IDE developed by ST. So that's a pin out. And the same story, you are going to expect SPI I2c serial ADC, so analog in our ADCs, 0.3 volts, 5 volts, SPI, serial, I2c, right? So all these things are pretty universal. You should be able to have it on each mainstream microcontrollers. They are kind of required. And get started. So I don't know if you can find this IDE in your start menu. If you do this and type ST-cube IDE, maybe you cannot find it, but try it. If you couldn't, go to the C drive. I think there should be a folder over there. And follow the steps. So this IDE is more complicated compared to Arduino. This is more professional. There are more functions involved. So you need to configure every single step. And pick up C. And so this is something you haven't worked with in the past. So it's called HAL Gpio. So that's a hardware abstraction layer. So they are actually just libraries. Right? So the HAL underscore something will be the general language for ST microcontrollers. You are not going to program every single thing because you need the libraries to facilitate your programming and your design. So the libraries here is HAL something, right? So you have to do this in order to enable or call that function. And here's a PDF, which has all the functions, like thousands of functions you can use. Just open that PDF and try to look for all these different APIs over there, which are available for you for different modules. So for GPIO, if you go to GPIO, you can see there are many GPIO functions. For example, HAL GPIO toggle pin. So this will just simply toggle that pin. Okay, and there are many other functions for the GPIO, and also for SPI, I2c the same concept. You can receive, read, write, do whatever you need for that module. See here, HAL delay. So that's a delay function. Delay for how long, right? And after you finished all the initialization for the software, you can see all these functions on the left-hand side inside IDE. Main.c, so you want to open that main.c as a main function. And you don't need to modify anything else because they are automatically generated by the IDE. They are already initialized by the IDE. So you just need to go to the while function, which is like the loop function in Arduino. It's just permanent loop. So it's going to run back and forth inside the while function. And so the GPIO toggle pin, you want to toggle A port, the port A, and number 5 in port A. So it's going to be toggled every second. So 1,000 milliseconds, right? So it's going to be toggled every second. And then build the project and run it. And okay. Yeah, just follow whatever here. So it's going to toggle this LED on the board. So the first one is just got you started, right, on this microcontroller. The next one, use a Uart, send a string to the serial monitor. So here you need to configure the pins because every single pin, they have different functions, right? So remember in MSP430, we saw that. So that one of the pins can do SPI, can do Uart as well, and also can be used as general GPIO pin. So that's why you need this type of configuration. So for example, I want to activate the Uart function of these pins. So I have to follow these ones and come back, and there will be a pin map or pin map for you on the monitor. You will see that on the monitor, and you need to go to here, find out the PA2 and PA3, which are the pins connected to the Uart module inside the microcontroller, right? But you want to let the microcontroller know that you are trying to use the RxTX function, the Uart, the serial communication function, but not something else. So you need to come over here and right click. So right click this pin. This is still on the IDE, right? So right click the pin and pick up UART-TX and UART-RX for the other one. So you can activate these two functions. So it's a graphical configuration. After you did this, they will generate a specific code or command in the IDE. So after you do this, they will initialize it for you in here, somewhere here on the top or at the bottom. You don't know, it's going to be somewhere. You know what I mean? So during the configuration process, it's actually generating the code for you, but you are not typing everything up yourself. You go to the pin map, you right click and activate the UART. So it's going to create a UART init or something, right, in the code for you. It's pretty convenient. You don't want to do all these redundant things, which is not the core function of the program, right? You just want to focus on the program itself. So right now we just want to focus on the blinking program. So we don't need to worry about anything else. Just in the while loop, blink it. And in the UART, same story. And we just worry about the serial communication. So here, right? So after the configuration, you open the main.c file, you'll see this. All right, so here, int, remember when we are using int, 8-bit int, we just want to specify this integer is an 8-bit integer. If you don't specify this in different computer systems, they have different definition for integer. In Arduino, it's 16-bit. In ST, I forgot. But in somewhere else, it's going to be a different length. So if you want to specify this is just 8-bit, and it's unsigned integer, but 8-bit, you want to do this. All right? Unsigned integer 8-bit. Here, that's the data, that's a string you want to send. And here's the function. And just follow the format inside the function. With the argument, you need the length in the size of the string. And here's the timeout, I guess. But refer to the data sheet, you'll see what are these arguments in this function. So this will transmit this string, this data, to the serial monitor. So it's going to send this data out from the TX port of the microcontroller. So whatever you connect to the TX will receive this string, right? Because we are connecting this one to the computer, so the computer is going to receive it and show it on the monitor. If you connect it to something else, and something else will receive it from the TX pin of the ST32 microcontroller. And time delay. So you can expect it's going to print hello world every 1 second in the serial monitor. And that's what you are going to see. And you can, because I don't think the ST IDE has a serial monitor, but you can use the Arduino serial monitor or any other, open source serial monitor available online. It doesn't matter. As long as it's a serial monitor, it's going to work. So Arduino is pretty easy to use, and you are familiar with that. So you can use it. Feel free to use it for this project, even though there's nothing to do with Arduino, but it's a serial monitor. And don't forget to change it to this kind of baud rate, right? Because I think I configured it as that speed over here. So you want to match it in your monitor. Yeah, and at the same time, you want to disable, because there are more than one UART modules in the microcontroller. So whenever you are using UART2, you want to make sure all the other ones are disabled. UR1, UR6 are disabled. And the code is provided already on the website. Yeah, that's the example code. And I have a typo here, for OLEG. So if you send the code here, will do this, right? So if you send something to the microcontroller from your computer, and it's gonna echo that back to you. So if I send a test, it's gonna show a test here. If I send the first color, it's gonna send it back. You know how that works, right? So in the serial monitor, you type it over there, you send, and it's gonna be sent to the microcontroller from TX, and it's gonna receive it at RX, right? And then it process it and put in the package for every byte, and send it byte by byte, and then being combined in the serial monitor afterwards. So you can see that exactly the same thing. So you are sending something to the microcontroller, and the microcontroller will receive it and send it back, right? And the very last one, I2c, the accelerometer, which you are very familiar with. I hope so. So find out the I2c pins and right click and activate it, so it knows you are trying to use the I2c function of these two pins, but nothing else. And make the corresponding hardware connections, and also the example code. And here's a microcontroller and being connected to here. And you don't need to pull up resistors because the MPU module has the 4.7K ohms pull up resistors for SD and SCL. So you don't have to do this again, actually. And you can receive all this data over here. And that's it. So the third tutorial, which is a tutorial for ST, worth 50 points. But put everything in one report, not 3. All right. Any questions? No? Great. That's it for today.